Well, hello everyone. Hello, my name is Nancy Gariché. I'm here from Canada. I'm born and raised in Montreal, so my first language is French. So if you're wondering what's the accent and you can't pinpoint it, that's what it is. It's French Canadian, not quite French from France. I'm part of the security and assessment team, security assessment and authorization team for the government Canada. I've been a public servant my whole career and been in security for at least the last 10 years. So today, what I'd like to talk to you about is about security tooling in your DevOps pipeline. So my plan for today, get my slide to move, is to talk to you about the foundational security concepts, right? Things that maybe if you're not in security, you're more in the development side that you're not familiar with. It might be things that you know about already, but we'll make sure everybody's on the same page. Then we'll talk about DevOps and DevSecOps, have some kind of definition. Are they the same or are they different? Then together we'll talk about security objectives and security tooling. So what are we trying to achieve and what kind of tools do we need to achieve them? And throughout the talk, I'll be talking about OASP, an organization that can help you build secure software. I'm not sure if you're familiar with it. If you're not, you should. And we'll talk a little bit about it and about my project. So that sounds like a plan? I hope so. Okay, so first, security, right? So when I ask people that are not like security professionals to define security, most of them define confidentiality pretty well. They're pretty aware of that. We don't want information that is confidential, that's not for everyone, to be disclosed to somebody that doesn't need to have access to that information. So that's pretty clear. And that's one of the pillars of security. But one pillar that is not, two other pillars actually that are not as familiar are integrity and availability. So integrity, which is I think always important, but for some industries is particularly more important. So we don't want our data to be able to change by anyone or only by authorized user. So we don't want our data to be altered. I think about industries like science, like banking, and hospital even maybe. So these are highly sensitive to integrity, and we really want to protect that part of that of information. And then there's availability. Of course, it's always an issue, or it's always not super convenient when you don't have access to your data or you don't have access to your system. But some business can continue. It's an annoyance, but they can continue business as usual. They don't have to stop if their data or systems are not available. But there are some businesses that absolutely need their data and their system right away, and that's availability. So those three pillars is what we're talking about when we're talking about security and having a secure system. And why I talk about this, because it's really the foundation of everything, right? That's how you make a decision on how you want to protect your information and your systems and how much resources, because you can't do everything. You can't protect it 100%. And you have to prioritize how you want, how much resources and energy you want to put in protecting your data. And these three pillars and the ratings that you give them will help you make this decision. And this can change. These ratings may change from business to business, from line of business, but you need to kind of understand what you're dealing with before you start devising a solution to protect your environment. And then another concept that's often said discussed in security is shifting left. What you might recognize in front of me is a version of a software development lifecycle. So basically, when you build software, you go through a project, you go through different phases. You gather the requirement, you design the solution, it's then developed, you test it, and then you deploy it so it goes into production. What happens with security, for some reason that we'll discuss eventually, we're often not invited to the party, or they only when you see final version, the little purple circle, that's usually when we hear about project teams, because often in businesses they ask that a system gets authorization from security before it is allowed to go to production. right? So we get a project team a week or two, like very soon before they deploy, they're like, security, can you give us authorization? These teams have been working on these systems sometimes months, sometimes years. And as a security professional, you're supposed to understand what they've done all these years and months and kind of reverse engineer them if they have documentation or not, depending, and ensure that it was done properly. That's a difficult task. What usually happens is vulnerability assessment and penetration testing exercises. That's someone often from external to the company, to the organization, and sometimes internal, that actually try to exploit vulnerabilities in the application, in the system, to prove that it's vulnerable, and comes back with a report for things to fix, often before to go to production. And sometimes the project's team can decide not to move forward with the recommendation and take the risk to go into production, or they take the time to fix it. But that's not the best way to do it. You can imagine why. Well, benefits of shifting left and let me go back to that slide. Why shift left? Because we want teams to come and talk to us as early as possible, left in the software development lifecycle as possible, so we can early pick up the mistake. And why is that helpful? Because it costs less. It costs less to fix a mistake that you catch early. If you catch it early, according to that graph, for example, I don't think the numbers are that important, but you realize that when you catch it early, it's a lot significantly cheaper to fix the mistake than if you catch it later. And also, like when you think about it, the comparison that you'll hear about often when you learn about shift left, they say if you build a house and you wait till the end of the building, of the construction, and you say, oh, I think I'd like to add another bathroom. You know what? That's possible. You can do it, right? But you're probably going to destroy things that you've already paid for. It's probably going to be awkward, right? Okay, let's move that room and make some space for this. So it's not going to be the best design, right? It's going to be awkward. It's not going to be as good as if it was planned for the beginning, and it's going to cost much more money. So that's what we're always trying to do. Yes, we need to be involved at each phase. Sorry, that one at each phase, but also as early as possible. So what did security do for that not to happen, not to only be called at the end of the project? Well, I call it the security superpower. That's gatekeeping. So at every gate, so I don't know if you see clearly the numbers, there's 1, 2, 3, 4, 5, that's at the end of each phase, and at the beginning of the other one, we require a security authorization before the security team, the project team, the engineering team can move on. So that seems to fix the issue, right? Like no team can go till the end without coming to see us. No, not quite. Why? Because it's impossible, because we're outnumbered, right? For 100 developers, you have 10 people in operation and 1 person in security. That's the numbers that are popular and accepted in the industry. But I've seen worse. I've seen a bit better, but it's never an equal ratio, right? It's always something similar to this. So imagine that person having to go through each single phase and being the gatekeeper for hundreds and hundreds of projects that sometimes don't even have the same stack, the same technology, and that's an unfair ask, basically. And now you can understand why security is not often the favorite person in a project, because they're taking so much time, not because necessarily we want to. Sometimes personalities in security or something else, but even if we're the best at our job and are great at it, like it's nearly impossible to do at that ratio. And it keeps getting worse. Why? Because engineering team and development teams are finding ways to get better and better, right? But security has to catch up with them and has their old ways of working. So what you see on the right is the waterfall model. That's the traditional. So you would go to requirements, go to design and development. It's similar to what I've shown previously, but it's one by one. But the problem with the waterfall model is that you don't get quick feedback. The business asks for the requirements, gives them to someone to design them, to build it. And by the time it's built, you might have something completely different because you didn't understand the requirement properly, but the business didn't have a chance to say, hey, that wasn't right. So that's how Agile came along. They say, let's take smaller bites and do the waterfall model, but over and over again for each of these models. So what does that mean for security? So you're going to gatekeep for each single sprint, because every time you go around the Agile lifecycle, you call that a sprint. That's even harder. And it gets worse for security. DevOps, Dev and Ops. There's many definitions for DevOps. Nobody really agrees, but I would say something that I think most people would agree is that DevOps, Dev and Ops, the project teams are finally working together, not in silos. It's not the dev building on their local machine and sending it to over the wall to Ops to take care of. They figured out that working together and not working in silos makes better products and faster delivery as well. So they're a happy couple, and they're quite happy, and they're doing well. What about security? Well, that's a famous slide. You've probably seen it if you've seen other DevSecOps talks. That's how it feels, right? Like they figured out how to be a great team, but your security, you're behind, and you're just like, what am I going to do? How do I actually catch up with them? Well, DevOps is probably that helps. It's a solution that can, the tooling that is developed with DevOps can help us come to a solution. But the hard question we need to ask is, given the limited security resources that we have, like people, time, and budget, what's the best way for us security to reduce the overall risk for the business, right? So that's what we need to figure out. And what can help us to do that, like I was saying earlier, when I talked about the 3 pillars of security, is to identify, okay, what do we need to focus on? What's really important for us? And to build our pipeline or our security checks along the pipeline correctly. Just move that over. So before I go through, I will go through a few checks, security checks that you can put in your pipelines. Of course, a security program has more than that. I'm focusing on activities that can be done in a pipeline. But first, let me define a little bit the CI/CD pipeline. So CI it's short for continuous integration, and it's a software development practice in which all developers merge code changes in a central repository multiple times a day. So that's CI. And the CD, that's the other part, it stands for continuous delivery, which on top of the continuous integration, it adds the practice of automating the entire software release process until it goes to production. So with CI, each change in code triggers an automated build and test sequence for the given project. It provides feedback to developers who made the change. The entire CI feedback loop should run in less than 10 minutes, right? And then CD, the continuous delivery, it includes more the infrastructure provisioning and deployment, which may be manual and consists of multiple stages. What's important is that all these processes are fully automated and which each run fully logged and visible to the entire team. So benefit of having a pipeline, it's that the developer can stay focused on writing code and monitoring the behavior of the system in production. So it gets feedback. The product updates are not as stressful. You can log all the code changes, the tests, the deployments are available for inspection at any time, pretty much. Rollbacks are easier. And really most important is the fast feedback loop that helps us build a good culture and good product, like contrarily to the waterfall model that we spoke about earlier, where we never had feedback. rarely had feedbacks, and we could end up with a product that is not at all what we asked for. So let's go. That's a summary slide of the different tools that we'll go through. We'll go to SAS, static analysis security tool, dynamic, DAST, SCA for software composition analysis. Then we'll talk about secret detection in our pipeline. We'll talk about container security. We'll talk about WAF. WAF stands for Web Application Firewall. And then we'll talk about infrastructure the new way, especially with cloud being the new thing. So before I move forward with all these things, I want to talk about OASP and make sure that everybody knows about that. OASP stands for Open Web Application Security Project. If I sound like a saleswoman, I don't mean to. I just really like OASP. And I need to not warn you, but tell you that it's a nonprofit. So I'm not, paid to tell you all about this. So they're a nonprofit. It operates chapters, projects, and conferences all over the globe. And it's basically powered by volunteers, by brilliant volunteers. And they create guidance, software, and like I said, communities. There's probably one close in your country, in your city, depending where you are around the world, but they're pretty much everywhere, and they have a lot of online resources. If you know, most people that heard about OWASP heard about the OWASP Top 10, which are the 10 vulnerabilities that we found most often in software. But that's only scratching the surface of OWASP. It's really just an awareness tool because there was a time, I think it's a bit different now, but there was a time where people were thinking about infrastructure when they were thinking about security. And the OWASP Top 10 really did a good job at making people aware that that security was also important at the application level, right? That it was not only an infrastructure problem, that if your application is not secure, that's a problem. So why am I talking about OWASP? They have a lot of tools, and some of the tools that we'll be talking about that are open source are from this organization. So if I say OWASP ZAP, OWASP dependency check, that is what I am talking about. Okay, so SAST, what I was talking about first, that's the static application security testing. So that's designed to analyze source code, bytecode, binaries. So your code is not running. They call it white box because you have access to the code, right? So from the inside out, in comparison to the black box code. So some example of that are Checkmarks, which is a paid product, PMD, which is free, Bandit, when you program in Python, Brakeman in Ruby. So, and PMD is for Java, Bandit for Python, Ruby. Because it analyzes the source code, static analysis tools tend to be different depending on the programming language that you're using, right? Compared to the DAST that we'll talk a little bit later. So, yeah, so there's security bug, Brakeman, Fortify, there's different products. So it's always important to not rely on only one tool. A good recommendation is sometimes to have an open source tool that is free and maybe a paid product, and take the time to tune them properly to not have too many false negative. And you may have to try different scanners before you find the tool that works best for your project. So it's worth that investment initially, so that if it doesn't provide good feedback for your developers, for your team, they won't use it. So it will be a waste of money. So it's really important. And that's actually true for all the tools. DAST, in comparison to the SAS, that's dynamic application security testing. And those tests are run while the application is running, right? So that's not depending on the language itself. Most DAST solution test only the exposed HTTP and HTML interfaces of web-enabled application, right? And because dynamic analysis requires code execution, it's much more costly and significantly slower. So like I said, it's called a black box. And one example of that tool, again, is from OWASP and it's free. It's called the OWASP Zap. You'll have OWASP, not OWASP, but Burp is also a tool that is not from OWASP. It's a paid tool. They have a community version. You might have still have heard of other paid tools like IBM Scan, AppScan, and Veracode. So they exist also for many languages and framework, but they're not as dependent as the SaaS tools. So next, SCA, software composition analysis. So we'll stay away from software for a minute, but I like to compare this category with food, right? Like if you're trying to bake your own pizza, to make your own pizza, and you take all the ingredients from scratch, you know exactly, and you're someone with allergies, for example, right? So you take your own ingredients, you make your dough, you have all your ingredients, you know what's in your pizza. But sometimes, right, you want to save time. You don't want to reinvent the wheel. So you go and take something ready-made. But because of your allergies, you need to find out what's in there. Yes, you save time, but whatever they put in there is going to come into your body and may have an effect on you. Well, that's a similar example with software composition. When we're building software more than ever now, we're actually combining different components. We're not reinventing the wheel all the time. We're taking things that already exist and bringing them in a project. We're bringing libraries, we're bringing components. But the thing we need to understand is that when we're bringing those third-party tools, we're also bringing the vulnerabilities they have in them. So it's really important for us to check that the components that we're importing, that we're inheriting, are free of vulnerabilities. And how you can do that, OWASP also has a free tool called the dependency check that can do that for you. I'll also pay to a very popular these days product is Snyk, SNYK. I don't know if you've heard of that, but those are also software composition analysis tool. And what's fun with these tools as well, they tend to combine licensing. So even if a product is open source, there's different type of licenses, and it's not always free to use for every use cases. So these are the things that a software SCA, a software composition analysis tool, can help you manage as well. So, and that's one of my favorite tools because compared to the SaaS and DaaS, it has very low false positive, right? If you have a vulnerable component or not, it's not as, I feel like SaaS and DaaS give you hints, help you decide, help you look further into an issue and decide if you need to fix it or not. But SCA really gives you a decision on what to do. Secret detection. You're probably familiar with that one, but that's a recurring problem that happens a lot is when developing software, engineers tend to commit secrets into their repository. And if their repository is public or somebody, a malicious user has access to that repository, they suddenly have access to these secrets. And secrets, whatever am I talking about when I'm talking about secrets? I'm talking about, of course, password, connection strings, tokens. So anything that gives you access to something more sensitive. So if they have access to that, you can imagine that they also will have access to the things that you were trying to protect with those secrets. So secret detection tools run into your repository, scans them to make sure that they cannot detect any type of secrets. Some things that go hand in hand with secret detection is having a secret store, right? I don't know if you've heard of tools like HashiCorp, Vault, and even all the cloud providers have their own tools. Azure has the Azure Vault, Amazon has one, so does GCP. So you can use the one that's more appropriate for your environment, but it's basically a way for developers to store their secrets so that they know how to manage them and they know where to put them, so that they don't commit them into the repository. that doesn't mean it's not because that you have a secret store that you wouldn't run a secret detection tool, right? You still would do it, but I think it's less likely that you will find secret if you have good processes and habits and a tool and a solution for your developers to store their secrets. And I've mentioned the tools, the secret store, but one of an example of a tool that does a detection is called Trufflehog, and that is also from HashiCorp. Again, I mentioned different tools just so that you can understand the category. I think what I'm trying to focus on is the type of tool, and I'm not endorsing or saying they're bad or good. I'm just trying to give you an example to understand what kind of category of tools that you need to integrate in your pipeline. And then there's containers, right? Containers are not that new anymore. We've been using them for a while, but there's an adoption of container orchestration platform, like Kubernetes and OpenShift, and we need to make sure that our containers are free of vulnerabilities. So they also have tools for them to be scanned and to make sure that they are compliant with the different best practices. So we have the Docker bench for security scans that exist. There's Docker security scanning. That's an add-on service from Docker. And there's also Clair, C-L-A-I-R. That's an open source one, vulnerability scanner for Docker images. So that's one that is slowly getting more into your pipeline if you're using containers. Not every business needs containers, but if you're adopting them, you definitely would want to scan them. WAF, that's a different one, right? Like WAF are usually, we usually implement them in production. But a web application, a WAF is a web application firewall. It filters and monitors and blocks HTTP traffic to a web application, to and from a web application. So it's different from a firewall. It's not for infrastructure, and it can predict it. It can, detect patterns and realize that it's an attack on your web application and stops certain attacks. But sometimes it is wrong. It also has false positive, and that can make your application not available, which is important, right? So if you put your WAF solution into your pipeline while you're building your application, it's an easy way for you to predict how it will react once it's in production. So that's a good habit to take, to use to integrate your WAF solution in your pipeline so you can predict how it will behave and do the proper adjustments before it's put into production. That also open source one, mod security, and OWASP doesn't have a WAF of its own, but it does open source the rules to configure mod security and the WAF, and you can detect and you can set the paranoia level that they call, like the sensitivity level that you want your WAF to have, and it's really a good way to make sure that you have the right level by putting your WAF in your pipeline. Next, infrastructure. That is really, to me, a really exciting change in technology in general, and in CI/CD and in DevOps, is that we used to, not too long ago, have to order servers, have to wait for them, have to wait till they got built and delivered, and to build a solution, it would cost a fortune and it would cost in time. But now we have access to the cloud and cloud service provider, right? And as long as you have a credit card and a bit of fun, depending on what you're trying to build, you can have access to your infrastructure. And it's great. You can go on the platform and provision what you need. When it's only for a small business or a few machines, a small infrastructure, it's not that bad. You can do it through the platform. But eventually, when you have a lot of machinery, huge infrastructure, it's hard to keep track of how they're supposed to be configured, right? If you're, did you really click here? Did you really click there? We've had a network not being performant at work for weeks because a check mark wasn't checked in a network appliance, right? And that's because it was done manually at the time. But with infrastructure as code, you have a source of truth. You have all the benefits of software development now, where you have version control, when you can have drift detection. By drift detection, I mean, well, you've set you built your infrastructure in a certain way, following your best practices and compliance rules, and maybe someone has access to the platform and changes manually the configuration. Well, it is our job to continually check the environment to compare with our source of truth. And that's only possible because we have infrastructure as code. That is not possible when you're clicking everywhere. So that's really exciting. So that is not a check in itself. That's a new way to provision the infrastructure. But with this new language, and for languages in AWS, it's called CloudFormation. Azure has ARM template. GCP has deployment manager, I believe. And there's one, HashiCorp, again, very popular set of tools that's called Terraform. That is a language that works for multiple cloud provider, right? So we use infrastructure as code. And for each of these languages, there is often a testing, static testing for infrastructure as code to make sure that you follow the best practices and that you're not building something that's insecure and that can also be in a pipeline. So that's a really new area, and that brings new possibility that is quite exciting to me. Maybe I'm just a geek. So that's the overall categories that we've been through. We've been through SAST for static code, for when you have access to the code, DAST, dynamic, when it's a black box, software composition to understand what are the components that we're building in, that we're bringing in into our solutions, secret detection, making sure that we're not leaking secrets everywhere, container, making sure they're not vulnerable, the WAF, be able to predict its behavior once it's in production, and we just seen infrastructure as code. There's a few other things I would want to add to all that. I know this presentation is called tooling, right? Security tooling, but DevSecOps and security within DevOps is not only about tools. It's important to know what you're trying to achieve and that there are tools that can do what you want to do. But you can't buy yourself secure. You can't just buy those tools and make sure that they work instantly. You need to have the people and processes to support that, to support the results, to make sure that they're accepted and they're part of their process. So yes, we did focus in this session today on the tools, but they're not the end of it all and the solution to your DevSecOps strategy. Don't always break the build. That's essential for you to still have friends at work. If you start breaking the build, breaking the pipeline every time you find something that's inaccurate, they're not going to like you. A pipeline is meant to be fast. It's meant to be reliable. It's meant to and to be accurate. So if you have tests that you're unsure of, let's go with point number 3, consider an asynchronous security pipeline. So that's a parallel pipeline where you can do all those tests that maybe have false negatives, maybe take longer than the 10 minutes that it's supposed to take to go through a fast pipeline. You may run that maybe once a week. You may run that overnight, but don't put it in the way. Don't make enemies. Do that on the side, and then take the time to assess the results and bring them back to your engineering team. That note. So I'll end with resources. I said I will sound like a saleswoman. OASP, the same slide reminding you that it's really a resource. Everything is free. And even just being part of the community is something super amazing, because you have people that really care about security of software, and they're accessible. You join their Slack channel, you join their conferences, and you can talk to them and ask for advice. It's been really a good resource for me. So I really share it with everybody. And I'm also a project leader for OASP. And what we've done, it was not started by me. It was started by my friends Tanya Jenka and Nicole Becker. And they started a project because it was at the beginning of DevOps, and it was hard for the industry to understand how security, and it's still hard actually, could embed itself into security. So they created that project, and myself and Francisca joined them in the project. And we're building different guidance and educational content for people to explore that. And one thing that we do pretty regularly is invite professionals from the industry to talk to us about what they've done in DevSecOps, and problems that they've been through or solutions that they found, and go through their use cases and have conversation with them, so that we learn and we share what we learn. So we're a bit everywhere. We're on Twitter, we're on dev.to and YouTube. Again, that's a project within OWASP, that nonprofit. And that's it for me. That's my thank you slide. Thank you for being here. Thank you for, I hope that was helpful and that was useful. My name is Nancy Gariché. Again, here's my email, and I can be contacted through LinkedIn. I'm not really on social media, but if you have any questions and that you can't ask here, feel free to contact me. I'm pretty open to that. That's it. Guess I should check my Slack. Thanks, Nick. I hope Nick. So many channels. 8. Yes, 8. Thank you. Good talk. Okay, no questions per se.
I just posted a question in the WebEx chat if you have the time.
Yes. You're completely inadequate. Where's the chat? Let me see. Was it the same one? As the OASP ASVS helped in integrity security in DevOps? Yes, absolutely. I'm like my heart, like that's where I started. I started with compliance, right? So not everybody loves that, but ASVS was the first standard that actually spoke English to me, that I could actually understand what they were talking about, and helped establish the baseline of what we needed to do to protect our application. Sometimes what makes security not very popular is that we take an incredible amount of time to provide security requirements to the engineering team. And that's because, you know, we deal with standards that sometimes have a bunch of controls that are irrelevant. And I feel like ASVS is a set of controls that is relevant, that is clear, and that we can select from, and that is reasonable to give guidance to our developers on how to build software. And not everything in the ASVS is possible to enter into the pipeline, for sure. Not what you put in your pipeline is not all your security program, right? The security program has threat modeling that's not in the pipeline, has bug bounties, has different activities that are outside of that. But some of them definitely come from ASVS, for sure.